Okay, so you're going to take that piece of graph paper that looks like this one, and you are going to put a parallelogram on it. For instance, you guys, a parallelogram has the opposite sides are parallel. So let's say I do something like this. I go from there to there, okay? What I would want to do is come down here somewhere, and I'm going to draw another line. And I want it to be, I went down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So I'm going to go over, down 1, 2, 3, 4, 5, and then over 1, 2, 3 from there. So those two lines are going to be the same length. So make sure you count, like I went down 5 and over 3. So from this one over here, I went down 5 and over 3. And then I connect them like this, and try to be exactly on where those grids lines intersect. Do not draw a rectangle with this, because rectangles, you guys, rectangles have properties that I should say, a parallelogram is, or a rectangle is a parallelogram, but it has additional properties than another kind of parallelogram. So I don't want you to draw a rectangle. Do not draw a rectangle, okay? I want you to draw a parallelogram that does not have right angles. Are we having trouble with this? Go ahead and draw another one. You got plenty of room on there. You don't need an eraser. Just draw off the side right there. You got plenty of room. Okay. Draw one that is not rectangular. Yeah, you could do that if that's what you want to do. Yeah. Okay, good. Okay. Okay, good. Almost done. Okay. One, two, three, four, 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Yep, that's good. I don't know why it looked weird to me. Yeah, I think it does. Well, don't do that. I think you have to hold it down. Oh, I forgot. I've got this thing on, don't I? Okay, looks like you guys have got them. Okay, now we are going to discover a few properties about parallelograms. The first thing I want you to do is measure all four sides to the nearest tenth of a centimeter and label them. Okay? So you're going to label all four sides and label them, how long they are, to the nearest tenth of a centimeter. So I'm going to measure this side right here, and it is about 6.2 centimeters. I'm going to come over here and measure this one. Okay. What did you guys discover about the sides of a parallelogram? Well, by definition, you guys, and we constructed this way, by definition, the sides are parallel. What else are they? What else could we say about the sides of a parallelogram? Okay. Opposite sides are congruent, right? Okay. So if you should have found out these two sides right here, like mine, are both 3.4, and the top and bottom are 6.2. Opposite sides are congruent. So I want you to write this down underneath that somewhere on that paper on the back side. Okay? I want you to write properties of parallelograms. And number one, opposite sides are congruent. I like to abbreviate by using the symbols. Opposite sides are congruent. Okay, now I want you to take your protractor that you have and measure all 4 angles of your parallelogram. Measure all 4 angles of your parallelogram. Okay. What do you learn right there, you guys? Say that again. Opposite angles are congruent. Okay. Does everybody understand that? Okay. So, did you guys find that out? Opposite angles are congruent. You spell opposite with 2 S's or 1? Okay. Just looked funny to me. Opposite angles are congruent. Okay? Now, I want you to add any two consecutive angles. Add any two consecutive angles on your paper. Okay? Actually do the addition off to the side like this. Okay, if I add up any two consecutive angles, like 58 and 122 here, or 122 and 58 here, or 58 and 122 here, or 122 and 58 there, what do I get? What do I get? 180. What do we call two angles that add up to 180? Supplementary. Okay, third property. Consecutive angles please don't, Kai. Okay, consecutive angles are supplementary. Okay. Now I want you to draw in the diagonals of the parallelogram. Draw the diagonals of the parallelogram. Draw in the diagonals of your parallelogram, and I want you to measure the length from a vertex to where the two diagonals intersect on all four of them, all four parts. Do you guys understand what I'm talking about? Look right here. You can measure from a vertex to where they intersect, that point where the two diagonals intersect. Measure all four of them. Okay. You guys, this is what you should have done. Measured from here to here and got, I got 4.2, and from here to here I got 4.2. From here to here I got 2.65. From here to here I got 2.65. Did you guys get something similar to that? You're within 1/10, which means you're probably off a half a tenth on each of them. 5/100ths. Okay. It's way off. 3.2 and 3.1. That's what? Measure again. Okay. Did you draw a parallelogram for sure? Yeah, you just got to measure from that point where you're supposed to cross, because that's kind of sloppy. Sorry. You're supposed to be an artist. Oh, that's your dad? Okay. All right. Okay. Should be pretty much on. Okay, what do we find out about the diagonals, you guys? What do we... Hey, you guys, I'd appreciate it if you'd listen so we can get through this. Okay. What do the diagonals do? Okay, what's a word? There's one word we can use that describes this. They mid-segment each other. Kind of, yeah, there's a word that we use for that. It's close. Doesn't really start with an M. When we cut two things in congruent halves, what do we call them? We say bisect, okay? The diagonals bisect each other. The diagonals bisect each other. Okay. The diagonals bisect each other. Okay? That's the fourth thing. Okay. I'm trying to remember if there's any properties of parallelograms, of a parallelogram like this that I haven't taught you. Okay, now, are the diagonals congruent? Okay. What are the diagonals congruent? Not to each other, are they? Okay. What I want you to do now, if you've got room on that piece of graph paper somewhere, I want you to draw a rectangle. Is a rectangle a parallelogram? Yes. A Mustang is a Ford, but not all Fords are Mustangs too, right? There you go. Really? Your definition is different than my family. All right. Okay. So we've got okay, draw a rectangle. Now I want you guys to draw the diagonals of this rectangle. Okay. Now, I want you to measure the two diagonals. Measure the length of the two diagonals. Because I needed to show you the other properties. Okay. My two diagonals are both okay. What did you find out about your two diagonals on your rectangle? Okay. Okay, number one, the diagonals of a rectangle are what? Congruent. Okay? The diagonals of a rectangle are congruent. Yeah. Hey, when a contractor is going to pour the foundation and pour the slab for a house, this is one of the methods that they use. I've seen it used by them before. They actually take two tape measures and they go out an equal distance on them, and they make sure that they have a certain place that they're supposed to bisect each other in the middle, and when they have them congruent, they know their sides are square. In other words, they know that they have a 90-degree corner right there. Because some contractors don't do this very well, and they get a house that looks square to them, but they eyeball it, so they get something that looks like this. And they pour their foundation. They think they have it because they have all the lengths right, but their sides are not square. So has anybody worked with somebody that they've seen them square something like this before? Sometimes they use a Pythagorean theorem to square things. They use a 6, 8, 10 triangle or something like that, take measures. But a lot of them use this method right here. Okay? Yeah. Say that again. Quadrilateral. What about it? Yeah. Well, you guys, everything that we learned about quadrilaterals, rectangles and parallelograms are a special type of quadrilateral, right? So the rules apply to them as well. Okay. So all these rectangles, all these parallelograms are quadrilaterals, but just an average quadrilateral. Do all the rules that we learned for parallelograms apply to an average quadrilateral? No, it has to be a parallelogram for it to apply, right? So all these properties right here. Okay, I've got 2 worksheets for you that we will do for the assignment for parallelograms. I'm going to let you guys work on them for a little bit. A rhombus is a parallelogram. He is right. It's a diamond, what most people call a diamond shape. A parallelogram with 4 congruent sides. I probably wouldn't use that one. Okay, just help you out a little bit. Now we know why you've been having trouble. Just kidding. All right. A parallelogram with 4 congruent sides. You guys all hear Kai? So, girls, if Kai starts whispering something in your ear like, "You are as beautiful as a rhombus in the sky," that's what he was whispering to Cameron over here just a second ago. All right. A rhombus has 4 congruent sides. A kite's not the same thing as a rhombus. No, I said it was a diamond. I said it was a diamond. A kite has one like this. That's a kite. Right there. Okay. So, you guys, if you turn a rhombus sideways, then it looks like a diamond. Hey, by the way, one more property for rhombuses. Not only are their diagonals bisect each other, but they are perpendicular to each other. So they are perpendicular bisectors. So write this down. For the diagonals of a rhombus, the diagonals of a rhombus are perpendicular bisectors. Have I showed you guys the symbol for perpendicular yet? An upside down capital T. The diagonals of a rhombus are perpendicular bisectors. You might want to put a little note right there pointing to that, saying perpendicular. You know what's hard about this curriculum, you guys? See, when we teach this in geometry, I teach all this stuff together, but for some reason, all I'm supposed to teach you about is parallelograms and rectangles, the properties of those. But when we learn them in geometry, we learn about all the properties together. I'm supposing that you guys are probably supposed to learn about a rhombus last year or maybe next year. I don't know for sure yet. A rhombus is not always a square, because a square a square can have 4 congruent. It has to have 4 congruent angles, 4 right angles. Whereas this right here doesn't have to. A rhombus does not have to. It's a parallelogram with 4 congruent sides. Okay, let me draw a little tree diagram to help you guys out with this. We have quadrilaterals. Okay, we have quadrilaterals. And under quadrilaterals, we have just average quadrilaterals. But under that, there's some special kinds. There's some called trapezoids. See, that's another thing. This curriculum doesn't bring up trapezoids, and I don't know why. And there's parallelograms. Now, there's 2 special types of parallelograms. Actually, there's 3. There are rhombi. rhombus and a rectangle. And then, if you put a rhombus and a rectangle together, you get a square. You might want to draw this tree diagram so that you for sure understand this. Okay? A trapezoid is a quadrilateral with exactly one pair of parallel sides. It looks like that. Or it can look something like this. Say that again. What does it say for question number 5? Yep, but that sounds like it's it right there. So you guys, a trapezoid has one pair of parallel sides, just so you know. A parallelogram has both pairs of opposite sides are parallel. A rhombus is a parallelogram because it goes under the heading of a parallelogram. So it holds all the properties of a parallelogram. But in addition to that, a rhombus has perpendicular diagonals, right? A rectangle is a parallelogram, so it holds all the properties of a parallelogram. In addition, it has congruent diagonals. Now, if you mix congruent diagonals and perpendicular diagonals, you get a square. And a square is also carries all the properties of a parallelogram as well. So a square is both a rhombus and a rectangle and also a parallelogram. It comes under that heading right there. Yes, a rectangle is a square. But a square is a rectangle, but a rectangle is not a square, not necessarily a square. Just like a Mustang is a Ford, and not all Fords are Mustangs, right? Or all Kai is a runner, but not all runners are Kai. Hurdler. I should say hurdler. Because I saw him run. No. Something like that. All right. Okay, we get that? The definition of a rectangle is a parallelogram with 4 congruent angles. Now, if they're going to be 4 congruent angles, what does every angle have to be? 90 degrees. But by definition, it's 4 congruent angles. Does everybody get that? Definition of a square is a parallelogram that has 4 congruent angles and 4 congruent sides. So a rhombus's definition is a parallelogram with 4 congruent sides, right? A rectangle's definition is a parallelogram with 4 congruent angles. If you combine both those, you have 4 congruent sides and 4 congruent angles, you get a square. Got it? So a square is the most specific type of parallelogram. Okay, it has the most properties. So it has the properties of both the rectangle and rhombus. So a rectangle has congruent diagonals, and a rhombus has perpendicular diagonals. Okay?